Hello, guys. Good morning. This is Prime Concept. I trust that you slept well. You had a great sleep. Of course, I wouldn't be expecting that you would have slept through the night. So, at least within this period of your exam preparation, to be like an active involvement, you should be actively studying. And I believe that you had a great night time of studies. So we are so sorry for the inconveniences that was caused by the network. So, but nevertheless, it's just a pointer to you that you're going to have a very great exams today. So let's see how far we can go with our revisions for this morning before you go for the exam. So we're going to see how much we can cover, and we're going to be very fast. So before we start, I just want you to register your presence, drop a comment, drop a like, drop a comment, drop a like. Invite your friends. There are so many people that don't know about this channel yet. Try to share this video with your class group. Tell them that Prime Concept is live. At least you should understand that whatever we're going to do this morning will hardly leave your brain just before you enter the exam hall. Drop a like for this video. Now, we're already considering vectors, and I'm going to summarize vectors in the next 10 minutes. We get to rotational dynamics, summarize, get to other ones and summarize. So vectors, we just finished resolution of vectors. I won't talk about it again. So let us go straight to multiplication of vectors. Multiplication of vectors. So, of course, in vector multiplication, we have three types of multiplication in vectors. We have four, of course, but I'm going to consider just three. So we have three types of vector multiplication. One of them, which I'll be handling first, is what you call the scalar product, or you don't want to call it scalar product, you call it dot product. Call it either scalar product or dot product. Now, why do you call it scalar product? Take note of the name. Remember, it is a vector multiplication, but you are calling it scalar product. Why you call it scalar product is because the outcome of the multiplication is a scalar. That is to say, when you finish carrying out this operation, the answer you will get is going to be without I, J, and K. So it's going to be a scalar. Very quick example. I'll be using an example to explain. Say A is 2I minus J plus 5K. And then B is, let's say, I plus 3J minus 2K. Now, say this is what you have, and they want you to find A dot B. This dot is what you call dot product, or what you call scalar product. Now, how do you do scalar product? You multiply those vectors in the same direction. Those are the ones you multiply, those ones in the same direction. So it means we're going to take 2I and I, we're going to take minus J and 3J, we're going to take 5K and minus 2K. Now what happens is you multiply out their coefficients. The coefficient of I here is 2, the coefficient of I here is 1. So if I say 2 times 1, it will give me 2. Now I'll leave I. The reason why you're leaving I is because when you dot two vectors, take note of this statement I'm making. It's an exam question. When you say I dot I, it will give you what? 1. When you say J dot J, it will give you 1. When you say K dot K, it will give you 1. And this is the reason why whenever you're multiplying, you ignore the I, because I dot I is 1. So 1 would go. Now, 2 times 1 is 2. Again, minus 1 times 3 is minus 3. Again, 5 times minus 2 is minus 10. When you add up this, what would you get? You get 2 minus 3, which is minus 1. Minus 1 minus 10 is minus 11. And what did you notice? You will have noticed correctly that our answer does not contain I, neither does it contain J nor K. And that is why we call this scalar product, because the outcome is a scalar. Now, just to add for you, somebody may ask, if you say I dot I is 1, what about when you say I dot J two different directions? What about when you say I dot k? What about when you say j dot k? What about when you combine different directions? What would this give you? This will give you 0, this will give you 0, this will give you 0. So don't forget that. Now, very quickly, I'll give you one problem, we move on. Now, A is 2I plus k, and B is 5j minus 2k. Find A dot B. Quickly drop the answer. Remember, one of the things that can sustain you this morning, keep you actively involved, is when you are with your pen and paper, you are solving, you are taking notes, so that by the time you're going for your own exam, while you are outside, you can be going through that quick summary we have done this morning. So drop the answer to this very quickly. Drop the answer. Drop the answer. Somebody's still asking, have you started? Oh. Chiebube, thank you. You said -2. We're going to verify. John Martin said 8. Okay. Please hit the like. Hit the like. It is enough sacrifice to be awake by this time doing this revision. So do well to support by hitting the like button. Drop a comment. Encourage us. We have many more quizzes to do so that we'll keep hitting them. Hit the like so you don't forget. Hit the like now so you don't forget. Before you continue, hit the like so you don't forget. Somebody say I can't see clearly. Please, is it the same for everybody or just one person? Please, if you can see clearly, let me know so that I will know. Should be network. Please, can the other persons see clearly? If you can see, okay, it's clear. Thank you. So let's solve. Please hit the like so you don't forget. Hit the like button so you don't forget. Now let's quickly solve this. Now notice that our A does not complete J, so it means it's not complete, and our B, something is missing, which is I. So what you should know is that anytime you are multiplying incomplete vectors, you are dotting them. Those ones that are not complete, ignore them. Only multiply those ones that are complete. What do I mean? If you check, the only thing I have in A that I also have in B is K. The only thing I have for A and I also have for B is what? K. I have I for A, but I don't have I for B. I have J for B, but I don't have J for A. So the only thing that is in both A and B is K. So that is the only thing I'm multiplying. So it means I'm going to say 1, which is the coefficient of K, times what? -2. And what will it give me? -2. So the answer is -2. So just a few persons got it. Now, again, I'm done. I don't think I need more examples here. Now, again, in scalar product, what we have done so far, this kind of multiplication we have done, though you don't need to know the name, but it is called algebraic multiplication. Why do you call it algebraic? Because it involves the component of the vector. Now, the next type of scalar, because under scalar you have two types. You have algebraic, which is what we have done so far. Then you have geometric. Under scalar, you have algebraic and geometric. Now, the geometric is used in finding theta. Geometric is used in finding the angle between two vectors, while algebraic involves components I, J, and K, like this, right? Now, what is the formula for geometric scalar product? It is simply A dot B equals magnitude of A, magnitude of B, cos theta. So you should know it. So that is the formula you need. A dot B, A, magnitude B, cos what? Theta. So very quickly, I will give you an example. Remember, I don't have calculator, so let's take this example. A equals, let's say, I minus K, and B equals J plus 2K. Find theta. Find what? Theta. So we want to find the angle between A and B. So you want to find the angle between A and B. Once they say angle between two vectors, you're using this formula, right? Now, in order for you to use this formula, you need to make cos theta the subject. So see what I'm going to do. I'm going to divide both sides by the magnitude of AB. I'm going to do it this way so that this can fizzle this. And I would have left with here cos theta is equal to A dot B over magnitude of A, magnitude of B. So this is what I'll be using to get the angle theta. Now, if you look at this very clearly, you'll see that for you to get this, you need to first find A dot B. And then after that, you need to find magnitude of A, then you need to find magnitude of B. So let's do this one after the other. So let's first find A dot B. So A dot B, if you look at this again, you see that A is incomplete and then B is also incomplete. So it means I need to only multiply those ones in the same direction, which is just K. So I'll say minus 1 times 2. So my answer again is minus 2 for A dot B. And I believe it is clear. If it is clear to you, please say it is clear, this multiplication. Say it is clear. So I'm only multiplying minus 1 and 2. Why? Because those are the only ones that are complete. I have I here, I don't have I here. I have J, I don't have J. So that should be clear to you. So A dot B is minus 2. The next thing I want to find is magnitude of A. Now, magnitude of A, I taught you magnitude in just the previous video. So magnitude is the coefficient of I, which is 1 squared, plus the coefficient of K, which is minus 1 squared. So if I solve this, this will give me square root of 1 plus 1, which is square root of 2. Now, if you punch square root of 2, what will it give us? I think 1.414. Now, the next is the magnitude of B you need to find, which is going to be square root of the coefficient here is 1 squared plus 2 squared. So what do we have? Square root of 1 plus 4, which is the square root of 5. So if you punch this, punch for me the square root of 5 quickly. Tell me the square root of 5 is going to be 2 point something. Quickly punch for me. So who has the answer? Who has the answer? Okay, 2.23. Thank you. 2.23. Now, we have gotten all we need. What I need to do now is to come and substitute into this formula. So I have cos theta, which is this now, equals A dot B. I have gotten A dot B to be minus 2. So I would say minus 2 divided by magnitude of A. Magnitude of A is 1.4. So I'll say 1.4 times magnitude of B. Magnitude of B is 2.23. So what do you do from there? You're going to now punch that, right? Yes. So you're going to punch that. Now you have cos theta equals, please punch this for me. Punch this. All you need to do is to divide that whole thing there. So you have 2 divided by 1.4 divided by 2.23. So I have minus 0.6406. So this is what I have. Now I want to find theta. I would say theta is cos inverse of minus 0.6406. So cos inverse. So somebody should punch and tell me theta. So we'll move on quickly. Drop the answer. Drop the answer. Please hit the like button. Hit the like button. I won't be happy if most of you are here benefiting and you don't want to hit the like. Please hit the like button. Don't forget, hit the like button. We have 68 participants and you need to bring the like up to 68. Hit the like button. So 129.84. Hit the like button, please. I encourage what we're doing. 129.84. 129.84. Who else? Who else is confirming 129.84? 129.8, 129.84. Okay, that is good. Please hit the like button. 129.84. Thank you. So this is our answer. So I think we should move on to the next point. Remember, we have to be fast, and that is why you need to be following us. Don't be distracted. Don't allow anything distract you. Now, if I can rub this, tell me move on. If you're done, maybe screenshotting or copying, say move on so I can rub. I want to give you some important deductions that you will be asking you from dot product. So if you are done, say move on quickly. Say move on. Okay, move on. I need some other persons to say move on. Please hit the like. Hit the like. Hit the like. I don't know those that are still here that have not hit the like button. Hit the like. Hit the like button, please. And subscribe if you have not done that. Now, let me tell you, there are certain things you need to know. We're still under scalar product. We're still under scalar product. Now, there are certain points that you need to know. Now, one, let me not improve them, but one of the points you need to know is that if two vectors are perpendicular, if two vectors are perpendicular, comma, their dot product is 0. If two vectors are perpendicular, when you say two vectors are perpendicular, it means that the angle between those two vectors is 90 degrees, right? So if two vectors are perpendicular, then their dot product or their cross product should be 0. So it means that A dot B should be equal to what? 0. Now see what exam will trick you with. They will tell you if two vectors are perpendicular, which of the following statements is true? If A and B are perpendicular, this is the symbol for perpendicular. I'm giving you a question now. If A and B are perpendicular, comma, which of the following is true? This is a question, and you'd see option A 0, option B 90, option C 180, option D the following is true for their dot product. So this is how you see it. Option A 0, option B 0 degree, option C 90 degree, option D 180. So who can tell me the correct answer? If you know the correct answer, drop it in the option quickly. If you know the correct answer, drop it in the option. Let me see. Quickly, who has the answer? So you see two ways they'll be getting you. So when you understand the concept, tick. So tell me why it is not B. Most of you are choosing option A. Why is it not option B? Why is it not option B? Why is it not option B? Tell me. Please hit the like button. Option B. Now, the reason why option A is correct is because option B is carrying degree. It is not degree we are dealing with. It is not angle we are talking about. It is 0. It means it would vanish. So if two vectors are perpendicular, their dot product is 0. Another term they can use for you are perpendicular, their dot product will vanish. They will use that term. Vanish means it becomes 0. So take note of that, and I will move on. So this is one. Number 2 point you should know, if two vectors are parallel, if two vectors are parallel, then A dot B is equal to the product of their magnitude. Don't forget this. Then A dot B is equal to what? The product. Then A dot B is equal to the product of their what? Magnitude. So number 3, if two vectors are anti-parallel. What do you mean by anti-parallel? Anti-parallel means that they are in opposite direction. Now look at what we mean. If you have something like this, it means parallel. They can use diagrams tomorrow to show you. When you see something like this, it means that these two vectors are parallel. But when you see something like this, it means that these two are what? Anti-parallel. Take note of that. If you see something like this, it means that these two are what? Perpendicular. So this is for case 1, this is for case 2, and this is for case 3. I hope you're understanding me. Now, case 1, we said if they are perpendicular, their dot product is 0, which means that the angle between these two things is 90, but their dot product is 0. If they are parallel, the angle between them is 0, but their dot product is what? Is equal to the product of their magnitude. Take note of them. If they are anti-parallel, the angle between them is 180 degrees, but their dot product and they are anti-parallel, then A dot B is equal to negative. So it's going to take negative. Please, I need you to really understand this point. So in this first case, the angle is 90 degrees, but the dot product is 0. In this second case, the angle is 0, but their dot product is equal to this. In this third case, the angle is 180 degrees. Please take note of these statements. They are important. Now, if it is clear to you, I want to move to scale to vector product. I believe I can rub this, right? Yes. Can I rub? Yes. So can I move on now? Say move on. Please hit the like button. I'm not happy with those coming online. Not happy with those coming online and they are not hitting the like button. Please hit the like button. Please, it is turn by turn. Vector is not unnecessary. Once we finish vectors, we will get into rotational dynamics. It's turn by turn, so don't be too fast. So we want to look at cross product. Number 2 type of multiplication is cross product. Cross product can also be called vector product. So is either you call it cross product or you call it what? Vector product. Now, why do you call it cross product? You call it cross product because of the symbol. So this is the symbol. This is the symbol for cross product. Now, before I move on, I just remember the point I need to tell you under scalar products. Please take note under scalar that A dot B is equal to B dot A. This is under scalar or dot product. You can see it that A dot B is same thing as B dot A, and this is called commutative property. It is called commutative property. They will ask you this, so you should know that scalar or dot product is commutative. Scalar or dot product is what? Commutative. Take note of this. Let's come back to this. Now this is called cross product because of the symbol cross, and you call it vector product because the answer gives you a vector. That is to say, when you finish this multiplication, your answer is going to carry ij or k. So that is why you call it vector product. So we are going to use an example to illustrate this very quickly. Say we have A equals, let's say, I plus j, and we have B equals, let's say, 2j minus 4k. Now, let's say this is what we have, and they say we should find A cross B. We want to find A cross B, which is cross product. We want to find A cross B, which is cross product. Now, the concept to use is to use a matrix. So please follow me so that you don't ask me to repeat it because of time. Follow me very keenly. Now, anytime you want to find A cross B, anytime you want to find A cross B, the first thing you want to do is to write I, J, and what? K. That is the first thing to do. Once you write I, J, and K, you then start with the coefficients of what you have here. The coefficients of A, and the one for I, coefficient of, so for A, what's the coefficient of I? It is 1. So I'll put it under 1. What is the coefficient of J? It is also 1. I'll put it under J. Now you notice A does not have K. There's no K, so I'll say it is 0. Now then I'll go to B. For B, what is I? There's no I for B. So I'll put what? 0. Then for J, it is what? 2. I'll put 2. For K, it is what? -4. I'll put -4. So that's the first thing you want to do. You want to be able to arrange it in the matrix form. So for your matrix, please take note. It is constant that here would always be plus, minus, plus. It is constant. This signs does not change. They remain that way. So it's always going to start with plus, minus, and plus. So how do we solve this? Very quickly, the concept is you start with I. I want to find for I. So I'll put I outside. I'll draw. Now, you close everything connected to I vertically and horizontally. So vertically, you close this. This connected to I. Then you also close this part connected to I, because this is linked to I. This is also linked to I. If you close here and you close here, what will you see? You'll be seeing 1, 0, 2, and -4. So you'll be seeing 1, 0, 2, and -4. The next, you go to J. Remember, J is carrying a minus. So you say minus J. You also draw this way. Now close everything connected to J. So this part is connected to J. I'll close it. This part is also connected to J. I'll close it. What can you see if I close these things? You'll be seeing 1, 0, 1, 1, and 0, 0, and -4. Right? Now, I'm done with that of J. So what will I do? I will close the part that is connected to what? To K. So this is K. I'll close this part that is connected to K. I'll close it this way. Now, what plus K? What can you see? You can clearly see 1, 1, 1, 1, then 0, and 2. So that's what you have, right? I believe it is clear. Now, what you have like this is a 2 by 2 matrix. What you had there was a 3 by 3 matrix. Now, what you have reduced to is a 2 by 2 matrix. So what you're going to do is you still have your I outside. This is how you multiply. Don't mix it. You multiply right first. You go right first. So you're going to say 1 times -4. 1 times -4. So you're going this way first. 1 times -4 is -4. You quickly put a minus. The moment you multiply 1 and -4, you quickly introduce a minus. Don't forget. If you forget that, you make mistake. 1 times -4 is -4. I'll quickly introduce a minus. Then I'll go the other way. 0 times 2 is 0. I'll put it there. Right? Yes, I'm done with that. I'll come for -J. -J, I'll do the same. 1 times -4 is -4. I'll quickly do what? Put a minus. I'll go the other way. 0 times 0 is what? 0. Then I'll go again, plus K. 1 times 2 is what? 2. I'll quickly put a minus. Then 1 times 0 is what? 0. So I'm almost done. What do I have? I have -4 minus 0 is still -4. -4 times I is -4I. I hope that is clear. Yes. -4 minus 0 is -4. -4 times -J becomes plus 4J. Plus. I hope you know why it's plus, because minus times minus becomes plus. Now, 2 minus 0 is 2. 2 times K is plus 2K. So we have been able to get A cross B. We have been able to get A cross B. If it is clear, say move on. If it is clear, say move on. Now, exam can also ask you, instead of asking you to just find A cross B, they can still ask you to find the magnitude of A cross B. The magnitude of A cross B. Now, remember, what we just found here is only A cross B. What if they now actually find the magnitude of A cross B? To find the magnitude, this is what they want us to get to, which we are done. I'm just giving you an extra. Say they want you to find magnitude of A cross B. You do what you have always known. You do this. So you use the first one, which is minus 4 squared. Use the next, which is 4 squared. Use the next, which is 2 squared. Then you get your answer, which is positive, right? Yes, I believe this is clear. Now, I want you to note this very quickly for me. I want you to note that A cross B is not equal to B cross A. Remember, in dot product, we said A dot B is equal to B dot A, and we said dot product is commutative. But remember, in cross product, A cross B is not equal to B cross A. So it means that cross product is not commutative. It is not commutative. It is not what? Commutative. Rather, cross product is said to be anti-commutative. So cross product is anti-commutative. It is anti-commutative. Why do you say it is anti-commutative? Because A cross B is equal to minus B cross A. This minus is what makes it anti. If it is clear, say move on. Let me move to the next part. If it is clear, say move on. We don't have time. Hit the like button. Hit the like button. Hit the like button, please. Hit the like button. Hit the like button. We have 106 and 69 likes. Hit the like button. All right. All right. You must smash your exam this morning. We are going to be unraveling the concepts in virtually all the topics. We'll keep doing this till the first batch will go, will continue. So now, can I rub this? Yes. We are still under cross product. We are still under cross product. In the next 5 minutes, I'll be done with vectors. I will enter rotational dynamics, and I trust to finish that in 20 minutes. So we are still under cross product. Please hit the like button. Subscribe if you are yet to do so. Share this video with your friends. Tell them to join. There is no other option to your final exam. Tell them to join. This is Physics 101. You will not be offering Physics 101 second semester. So you have every right to get an A in Physics 101. It is your right. Now, cross product. Remember, I told you that we have arithmetic. We have arithmetic cross product, which is what we have done. This thing you are seeing is what you call arithmetic. Whenever you are using the component, you are dealing with arithmetic. Then you also have geometric. Geometric. Anytime you are looking for angle, it is geometric. Geometric. So geometric cross product is used to find angle. What is the formula for geometric cross product? It is A cross B, like this, equals magnitude of A, magnitude of B, sine theta. Take note of this formula. Notice that your A cross B is carrying magnitude. Your A cross B is carrying what? Magnitude. Notice that. Is that clear to you? Yes, and notice again that it is sine for cross product and it is cos for scalar product. So see the inverse. C, S, Y for scalar product. It is now C. See, they interchange, so don't forget it. Now, I'm going to use this question. Okay, let me use another one so I can still help you digest this concept more. Now, let's take an example. Remember, whenever you are using this formula is when they want you to find the angle. Now, say they give you A equals I and B equals 2I plus J. Now, say you have this, they say find the angle between A and B using cross product. Now let me tell you something, let me hint you. Remember, you can find angle between two vectors using cross product or using scalar product. If you get to exam and they say find the angle between two vectors, and they did not specify which method to use, please, you are using scalar product. You are using what? Scalar product. You are using what? Scalar products. Please take note of that. I hope that is clear. If they did not tell you using cross product, then you have to use scalar product. I hope it is clear. Yes. Now, let's just see how to use it. Normally, I shouldn't have done this. So now, if you want to do this, the first thing you want to find is A cross B. That's the first thing you want to find. And you're going to find this using your metrics. I can actually multiply these things without using metrics, but let me just be using metrics. So for metrics, I have I, J, and what? K, right? So for A, the coefficient of A is just I. It's just what? 1, sorry. So 1. Then A does not have anything again. For J is 0, for K is 0. So I'll put 0, 0. I'll go to B. So B, the coefficient of B is 2, 1. 2, 1. And then this becomes 0. So quickly, I would have that A cross B. I'll start with I'll draw my 2 by 2 matrix. Remember, this is plus, minus, plus constantly, right? Yes. So if you close I like this, what can you see? You see 0, 0, 1, 0, 0, 0, 1, 0. Then I'll go for minus J. Do the same. If I close J this way, I close this and close J this way. Close this, you see 1, 0, 2, 0. 1, 0, 2, 0, then plus K. If you close K this way, if you close this way and close this way, you would see 1, 0, 2, 1. 1, 0, 2, 1. Is that what you're seeing? Yes. Is that what you are seeing? Yes, I believe that is what you're also seeing. So I have I. Now what do? You cross multiply. 0 times 0 is what? 0, you quickly put minus. 0 times 1 is 0. Then I'll go to the next, minus J. 1 times 0 is 0, quickly put minus. 0 times 2 is 0. Then plus K. 1 times 1 is 1, you quickly put minus. 0 times 2 is 0. I believe this is very clear to you. So now 0 minus 0 is 0. 0 times I is 0, so it will go. 0 minus 0 is 0. 0 times J is 0, it will go. 1 minus 0 is 1. 1 times K is what? K. So it means A cross B is actually equal to what? K. Is that clear to you? Yes. Now, the next thing is you need to find the magnitude of A cross B. The magnitude is just going to be 1. What's the coefficient of K? It is 1, so squared. It doesn't have I, it doesn't have G, so it's just 1 squared. So what is 1 squared? 1 squared is 1. What is the square root of 1? The square root of 1 is 1. So it means that the magnitude of A cross B is actually going to be 1, which is just the coefficient of K. You don't need to do it. If you have only one vector, one unit vector, the magnitude is the coefficient. You don't need to solve. If I ask you what is the magnitude of 2i, the magnitude of 2i is 2. If I ask you what is the magnitude of minus 2i, the magnitude, remember, magnitude is always positive. The magnitude of minus 2i is going to be 2, not minus 2. So now I believe this is clear to you. The next thing you want to find is the magnitude of only A. See the formula we are using. We have been able to get magnitude of A cross B, which is this. We want to get magnitude of A. So magnitude of A, where is our A? So remember, A is I. Please, what is the magnitude of A going to be? You are correct. It is going to be 1. I don't need to solve it because it is going to be the coefficient since it's only one unit vector. Now, what about the magnitude of B? The magnitude of B is going to be the square root of 2 squared plus 1 squared. So what do I have? It is going to be square root of 5. You said it's 2.23, I think, from the other time. So we have this. Now we can find what we are looking for. So we can find our answer. Now remember, we're trying to find the angle. So the angle is going to be from sine theta equals this. divided by magnitude of A, magnitude of B. So this is the formula from where we're going to be finding it. So you have sine theta equals magnitude of A cross B, we have gotten it as 1. So it equals 1 all over magnitude of A is also 1. Magnitude of B is 2.23. So if you punch this, it would give us 1 divided by 0.4484. So it means theta becomes sine inverse of 0.4484. So give me the answer quickly so that we can move on. Quickly, give me the answer. Who has the answer? Hit the like button. 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 Who has the answer? You say the answer is 26.64. Thank you. 26.64 degree. That is the answer. So somebody was asking, how do we multiply that without using metrics? You can do that anyway. I can teach you like 3 methods, but you may not like one of the methods. So, but if you have just a simple vector like this, A equals I, and you have B equals 2I plus J, I'll show you how to multiply. Once it's simple like this, I'll show you how to multiply without using this. But can I rub this so that we can move on? Can I rub this? Say move on if you are done with this. Say move on. Say move on. Say move on quickly. Let's be fast, as I want to be carrying all of you along. Say move on. Say move on. Say move on. Say move on. Thank you. All right. Now, before I solve that, I want to show you something. I need you to know that let's do it this way, I, J, and K. I need you to know something from this. This diagram is very important. I, J, K. I can put it anyhow. I can say I, J, K anyhow you want to follow. But make sure it is going this way. Make sure it's going. It can even go the other way, but don't confuse yourself. Let's choose this direction, right? And this would help you know that I cross J. I cross J. Where is it tending to? It's tending to K. So I cross J is equal to K. I repeat. If they ask you in exam, what is I cross J? What will you say? It is K. How did I know? Because I crossing with J would go towards K. Again, if they ask you what is J cross K, what would you say? You would say J cross K. Where is it going towards? It's going towards what? I. You are correct. Now, if they ask you what is K cross I, what will you say? K cross I is going towards what? J. So it's going to be J. I believe this thing is very clear to you. Now, somebody may ask, what if they now say I cross K if they are going back? You are correct. Your answer is actually correct. If they ask you I cross K, what did you notice? You are going opposite. And in vectors, anytime you're going opposite, what do you use? Minus. So I cross K, where is it going? It's going to J, but in opposite direction. So it becomes minus J. If they ask you what is K cross J, K cross J is opposite. So it's going to be what? Minus I. What about J cross I? What is it going to be? J cross I is going to be opposite minus K. So I believe this is well noted. Again, somebody might ask, what did they say? I cross I. What will it be? Same direction. And you are crossing is 0. Remember, if you say I dot B, I dot I is 1. Don't mix these two things up. When you are dotting and they're in the same direction, it is 1. But when you are dotting and they are in different direction, is 0. So don't mix it up. But when you are crossing in same direction, it becomes 0. So J cross J is 0, K cross K is 0. Please understand the difference. If this thing is well noted, say move on. Say move on. If it is well noted, say hit the like button. There are about 12 persons that are yet to hit the like. If it is well noted, say move on. Thank you. So now you want to solve this. You do your normal multiplication. You want to find A cross B. So remember, A is what? I. You are crossing it with 2I plus J. So this is normal thing to do. So you have, watch. What is the coefficient here? The coefficient of I is 1, right? So you'd say 1 times 2 is 2. Do you agree? Yes. Now, what is I cross I? What is I cross I? Is 0. So it means that this part becomes 0, right? The next thing you do is to do this one. So 1 times 1, the coefficient of J here is 1, the coefficient of I here is 1. So 1 times 1 is what? 1, right? Yes. Then what about I cross J? What will I cross J give you? From what I just gave you now, what will I cross J give you? To give you K. So it means that, remember, this part is already 0. So it means that your answer is 1K, which is just K. If it is clear, say it is clear. Let me explain again with another example. Say you have A equals 2J, and then you have B equals, let's say, 4I plus, let's say, 3K. Let's say you have this. Remember, this method will be easier if what you're multiplying is simple, if you don't have so many things to multiply. So you have A cross B equals 2J into 4I plus 3K. Say you have this and you want to multiply this. Is your normal expansion. This times this times this is the normal expansion you do in maths. But you have to be careful while doing it. So 2 times 4, you know, is 8. Then J cross I. J cross I, remember, is opposite. So it's cross K. You go again. 2 times 3 is what? 6. Then you say J cross K. J cross K, what will it give you? It will give you what? I. J cross K will give you what? I. So what do you have? So you can quickly say that this is 6I minus 8K. If it is clear, say clear. If it is clear, say clear. If it is clear, say clearly, so that I'll move on. If it is clear, say clear. Okay, you say it's now clear, so I can move, right? Clear. All right. So the last part of vectors, and I'll move out of this. The last part of vectors. So the last part of vectors is, remember I said 3 types of multiplication. We have done scalar product, we have done cross product. The last one I want to give you is what is called scalar triple product. Scalar triple product. Scalar triple product is given as A dot B cross C. And if you have 3 vectors, A, B, and C, then, and you have the multiplication in this order, that is to say dot before cross. When you have it like this, this is what you call scalar triple. Why do you call it scalar? Because the outcome of this multiplication is going to be a scalar. Why do you call it triple? Because you have 3 of them, A, B, and C. So that's why you call this scalar. It must not be the alphabet A, B, and C. They can use different alphabets. They can use D, E plus F. You can use this, but the pattern is you have dots, and then you have cross. Is that clear to you? Yes. So this is what you call scalar triple product. Now, see what exam can ask you. You should know that A dot B cross C as C dot A cross B dot C cross A. These three things will be the same answer. Somebody may ask, how did you form this pattern? It's very simple. See what I have done? Let me use this one. The pattern can also be created here. See what I've done? I just move F behind D. If you move F behind, then you have F, then D and E. If you move F behind, you have F, D, and E. So you have F dot D cross E. That is the pattern. Then to get the third one, you move E behind F. You have E, then you have what now? F and what? D. That is the pattern. So these three are the same. The exam can ask you, one of the following is different. So one of the following is different. They will give you this as option A, give you this as option B, give you this as option C, give you a fourth option that is wrong. So take note of the pattern. Once they give you that pattern, you can always form the rest. Is that clear? Yes. How do you solve this kind of problems? How do you solve this kind of problem is what you already know. You can first of all find the cross product, then find the dot product. But under exam condition, you don't have to go through that method. It's time consuming. And let's take an example. Say A is 2i plus j, and B is I plus k, and then C is j plus k. So you have this, and they want you to find A dot B cross C. And they want you to find A dot B cross C. Let's quickly solve it. So let's quickly solve this. So we want to find this, right? So the short way to do this is to arrange this in a matrix form. So A dot B cross C, I will arrange in a matrix form. But this time, anytime you are looking for scalar triple, you don't need to use I, J, and K. You don't need to use I, J, and K. You start from the coefficient of A. What are the coefficients of A? The coefficients are 2, 1, and there's no K, so I'll say 0. And what are the coefficients of B? The coefficients of B are 1, there's no J, so I'll say 0, then K is 1. The coefficient of C, what are the coefficients of C? There's no I, so I'll say 0, then J is 1, then K is also 1. So this is what you do when you want to solve this. You arrange, you don't need I, J, and K. Why don't you need I, J, and K? Because it's already complete 3. Why we used to use I, J, and K before is just so that it will be 3 lines. Put I, J, and K in the first line, second line, third line. So but this time we have 3 of them. We don't need I, J, and K again. So what is the idea? Still the normal metrics you have known, plus, minus, plus. Still the normal metrics you have known. So what will you do? You start with the first one, which is 2. You create your metric. So you close everything connected to 2. You close this, and then you close this, right? You close it this way, you close it this way. So what will you have? 0, 1, 1, 1. The next thing is minus 1. You close everything connected to 1, like this, and like this. So what can you see? 1, 1, 0, 1, 1, 1, 0, 1. Then what's the last part? The last part is plus 0. Close everything connected to 0. You close it, and you close it this way. So what can you see? 1, 0, 0, 1. 0, 1. Then you do your multiplication, right? Yes. So you have 2 into 0 times 1 is 0. You quickly put minus. 1 times 1 is 1. Minus 1 into 1 times 1 is 1. You quickly put minus. 1 times 0 is 0. Plus 0. Now this is 0. Whenever you have 0, you don't even need to do anything, because you know that 0 multiplying everything inside this bracket will still give you 0. So this part is useless to us because 0 is outside there. So what do we have now? 0 minus 1 is minus 1. Minus 1 times 2 is minus 2. 1 minus 0 is 1. 1 times minus 1 is minus 1. So what do we have? Minus 2. So our answer, you can see, is scalar. That's why you call it scalar triple product. Will not carry I, J, and K. So I believe it's clear. Now I am done with vectors. I want to go into rotational dynamics. Rotational dynamics. If we are good to go, say move on. If we are good to go, say move on. If we are good to go, say move on. Somebody says -3. Oh, thank you. My God. -1 -2 is -3. Thank you. It's an oversight. Thank you for that observation. All right. I hope we can do that. Rotational dynamics. Yes. All right. So do well to share this. Invite your friends. Tell them to just come and join this class to help them. In case you have not prepared so well before your exam, of course, I'm not telling you I'm giving you all exhaustive questions, but at least I would help you be very fast in your revision. I would help you remember these things very fast. There are areas you still need to touch on your own. So once I do this and you're trying to now read through it very fast to revise, you see that your reading will be very fast for you. So that is what I'm trying to do. Touch necessary areas I can touch. There are still areas on your own. You read up and know those ones, then go for your exam. Trust me, you're going to come out with A. Now, rotational dynamics, and let me just point out, usually there are some students that were complaining about Chem 107, that they solved some problems, they didn't find the answer. It is normal, especially with physics. I have observed over time that some of the times when you solve physics problems, you will not see the answer in the option. So, and it is now as a result of oversight. So don't be discouraged. Once you solve, you don't see, don't waste time. Tick the nearest and move on. Don't waste time. Don't leave it blank. Tick the nearest option and move on to the next. Or maybe you can complain. If the lecturer is in the exam hall, you complain, then they'll tell you what to do. Now, rotational dynamics of rigid body. That is the full topic of rigid body. Now, you notice that there are 3 terms you need to know here. One of them is rotational, the other one is dynamics, and the other one is what? Rigid body. So these 3 terms forms this topic. So you need to understand them. Now, when you talk about dynamics, dynamics means a system that is what? Changing. A system that is what? Changing, right? Yes. Now, dynamics under physics is the study of motion with respect to the force that is what? Causing the motion. We have 2 areas of motion that we usually study. One area of motion, this thing I've explained now is an exam question. So we have 2 areas of motion that we usually consider. Motion, we study motion in 2 areas. One of them is kinematics. The other one is dynamics. So you'd always hear kinematics of motion, dynamics of motion. So we study motion in these 2 areas. Now, kinematics is an area that studies motion without considering force. Without force. It studies motion without considering. It means that under kinematics, you'll be talking about velocity, displacement, acceleration, right? So these are what you talk about under kinematics, but you will never mention force because you are not interested in the force causing the motion. But under dynamics, you are interested in force. Interested in what? In force. So dynamics studies motion with respect to the force that causes that motion. And that is what we're going to be seeing in this case. We are very much interested in force under rotational dynamics. We want to study rotation of objects with respect to the force causing the motion, right? Yes, so in this case, we're talking about force, acceleration, and so on. So that is dynamics. Now, when you talk about rotational dynamics, of course, you know what rotational motion is. Motion that moves about a fixed point. Motion of an object that is moving about a fixed point. That is rotational motion. Then what are rigid bodies? Rigid body is a body in which the relative position between the particles of that body is constant. A rigid body is a body or is a system in which the relative position between the particles at every point in time remains what? The same. That is a rigid body. So if you have something like this, you have your, let's say, your desk, your table, your desk, it is a rigid body. And I hope you know that according to the Brownian law of motion, it says that every of these things are made up of particles, so many particles, and the particles are in constant motion. So it means that the particles of your table, they are always vibrating. So let's say you have a particle A, you have another one, particle B, you have another one C, you have another one D. For this thing to be a rigid body, it means that this distance, this distance, they will remain the same no matter how you turn this table. The distance A to C would always remain the same. So a rigid body is a body in which the relative position between two particles remains constant. No matter what you do, it remains constant. So I believe I've explained what the topic is. So we want to study how rigid body rotates, the rotational dynamics, the force that is causing rigid bodies to rotate. Now, in order for us to study this topic, there are some terminologies that we need to know. One of those terms is what we call moment of inertia. Moment of inertia. Moment of what? Inertia. The moment of inertia is denoted by the symbol capital I. Now, anytime you hear moment, in our class yesterday night, I explained to you that moment is a general term. You can have moment of a force. You can have moment of inertia. You can have moment of mass. You can have moment of center of mass. So you can have moments of different things. So what we are looking at now is moment of inertia. Now, before I explain moment of inertia, I want you to know, recognize this term inertia. What is inertia? Inertia is the reluctance of a body to change in its state of motion. Inertia is what? The reluctance in a body to change in its state of rest. That is to say, when an object is moving, it doesn't want to stop. That is inertia. When an object is at rest, it doesn't want to move. That is what? Inertia. It is reluctance to a change in its state of what? Motion. So, what is moment of inertia? Now, listen. Moment of inertia is a measure of the ability of a body to resist the effect to its change in a state of rest. I don't know if you understand what I'm explaining. Moment of inertia is a measure of the ability of a body to resist the effect to its change in state of rest. Maybe I should write it. This is a measure of the ability of a body to resist the effect of a change in its state of rest. So that is moment of inertia, and it's very simple. Just I want to save your time by not doing too much explanation. For example, let me help you quickly understand this so that we can move on. What does moment of inertia actually mean? Now, if I bring two objects, say I bring a football, football, I bring football and I bring this marker and I roll both of them on the floor. I roll both of them with same force. I roll both of them on the floor. And both of them started rolling the same time from the same point. And they roll. Which one of them do you think will stop first? When they are rolling, which one will stop first? of course, the one that will stop first is the marker. The one that will keep rolling is the what? Is the ball. So which one of them has a higher moment of inertia? The one that has a higher moment of inertia is the ball, because the ball has the ability to resist what is trying to stop it. So the measure of the ability to resist any change in the state of motion, that ability is what you call moment of inertia. So the one that keeps rolling, that does not stop early, has higher moment of inertia. Now, again, you should understand that since that ball has a higher moment of inertia, it means it will not stop first. Now, again, when you want to roll it, it will be more difficult for you to roll that ball. So when that ball is resting, it is difficult for you to set it in motion. When it is set in motion, it is difficult for you to stop it. That is moment of inertia. I believe it is clear. Now, what is moment of inertia? Inertia's formula. The formula for moment of inertia, if you have a system of particles, that is to say you have so many particles, then moment of inertia is the summation of the mass times r squared. That is the moment of inertia. That is the formula, mass times r squared. Summation if you have so many particles, right? That is to say you would say m1 r1 square plus m2 r2 square plus m3 r3 square. If you have maybe 3 different particles, they say find the moment of inertia. You do the first one, do the second one, do the third, you add them up. If you have 4, you keep adding. That's moment of inertia. Now, what is one of the things you should know? The unit. The unit is kilogram meter square. That is the unit. What is another thing you should know? It is a scalar quantity. It is what? A scalar quantity. Is it clear to you? Yes. Now, let me give you one example. Let me give you one example. So, find the moment of inertia of a body with particles of mass m1 equals 2 kilograms at r1 equals 0.4 meters, m2 equals 5 kilograms at r2 equals 1.5 meters. So quickly, who has the answer to this? If you have the answer, drop it. Let's move on. So I'm giving you 30 seconds. I'm giving you 30 seconds. Who has the answer? This physics is for everybody. It's the same thing. It's physics 101. It's for engineering, for life science. It's for everybody. I didn't get your question. Divine Praise, I don't think he did. I don't understand the question. Please ignore vectors. We are done. We're in dynamics now. We don't have time. We don't have time. So I finish explaining a particular point. You don't understand it. Ask immediately so that we are moving at the same pace. All right. So I'm waiting. Oh. Nobody has gotten the answer yet. My God. Abi, do we have a break in transmission? Okay. Lone wolf. All right. Let me solve and move on. Now, for me to do, now you notice I have 2 masses, Abi. So it means that my moment of inertia is going to be m1. Using this formula, is going to be m1, 2 times r1. What is r1? 0.4. 0.4 squared plus m2 is 5. 5 into r2. r2 is 1.5. So this is what I'm saying. If you have so many, you just keep adding them up like that. So quickly, this is going to give us 0.4 times 0.4 times 2. So this is 0.32 plus 1.5 So this is 11.25. So what is our answer? 11.57 kilogram meter square. So that is the answer. Who got it? Who got it? Okay. Okay. Yeah, I think everybody got it. So let me move on. So that is moment of inertia. Remember, we're talking about the terms we need to know. Moment of inertia. Now, another term we need to know is what we call radius. Number two is rotational. So number two is geometric radius. Let me start this way. Geometric what? Radius. Now we have two kinds of radius we are dealing with. Geometric radius, which is r. That is this r you have been seeing, right? Geometric radius is the radius of the actual body. Is the radius as a result of the shape of that body. So if you are dealing with a cylinder, you know the radius of a cylinder. If you are dealing with a sphere, you know the radius of a sphere. That's geometrical radius. The radius as a result of the geometry, the shape of that body. So you don't need this so much, but you just need to know. Number three is what we call radius of gyration. Gyration, or you can call it radius of vibration, or radius of vibration, or you can call it rotational radius. Radius of gyration, radius of vibration, or rotational radius. The symbol for that is K. The symbol for radius of gyration is what? K. Now, of course, I have already explained it by giving you these other names. I've explained what radius of gyration means, something that is bouncing, vibrating. So that's why you can call it radius of vibration, right? So radius of gyration, I don't need to explain it, but radius of gyration is the radius that would give an irregular body the same moment of inertia as if that body that is irregular what was a point mass. So I just believe you understand. Because while we talk about radius of gyration, this topic is very important, especially to engineers, mechanical engineers, particularly and metallurgical engineers. Now, when you're dealing with parts that are irregular in shape, and for these irregular shapes, you cannot get their geometric radius. You can't get their geometric radius because it's not a regular shape. Remember, radius has to be from a point on the circumference to the center. But you notice that because it is irregular, it will not have geometric radius. So since it is irregular, the radius it should have is what you call radius of gyration. So radius of gyration is that radius that would give this irregular body same radius as if it was a point body that has a regular shape. That is radius of gyration, and I believe this little explanation is clear to you. Now, we have a formula for moment of inertia in terms of geometric radius, which is what I gave you before. I gave it to be I equals mr squared. Now, moment of inertia can also be given in terms of radius of gyration. It's going to be I equals mk squared. In terms of radius of gyration is mk squared. In terms of geometrical radius is what? Mr squared. Now, see what exam will be asking you. Since we want to deal with different shapes, exam will be asking you what is the radius of gyration for a sphere, for a cylinder, for a disc. So we're going to go into that now right away. So we are done with basic terms that you need to know. The terms I explained are moment of inertia, geometrical radius, and radius of gyration. These are the three things I explained to you. Now, we have different shapes, and those different shapes have their moment of inertia. Now, I need you to understand, remember, we are dealing with rotational dynamics. Rotation, how a body, when a body rotates, how does it behave when it rotates? So, for example, if you have this meter rule can rotate through the center. if my hand is the axis, it can be rotating through the center like this, like this. This meter rule can also rotate through the end this way. It will be rotating. I believe you understand what I'm trying to explain. This marker, this my hand is the axis of rotation. It can rotate through the end like this, and it can also rotate through the center this way. That is what we are going to be looking at. So we want to look at moment of inertia, moment of inertia for different shapes. Moment of inertia for different what? Shapes. So, all right. Shape. Now, one of the things I want you to take note of, is that for every shape we are considering here, we are assuming that their axis of rotation is about their center. About their what? Center. Their axis of rotation is about their what? Center. Just understand this. Let me not explain it too much. So the axis, we are assuming that the objects are rotating through their centers. That is the formula I will give you. Now, anyone that rotates through any point other than the center, I will tell you. So, number one, we want to consider is what we call a ring. You know a ring, the ring you normally wear in your hand. That is a ring. One of the things you know about a ring is that the ring looks this way. This way. This hole, this hollow part is very big. That's what makes it a ring. If you have something like this and you now have small hole, now if this hole that is at the center is very small, then it is no longer a ring, it is a disc. But if the hole is very big, it's a ring. That's why you wear ring if you check rings. So we are looking at a ring, of course, that is rotating through the center, So what is the moment of inertia? It is mr squared. Now, this is what the exam will be asking you. They can even ask you for these formulas without asking you to calculate. Please take note of it. They may not even want you to use it to calculate. They just want to know if you know the formula. Yes, so that is the moment of inertia. Number two, when we are dealing with a sphere, a solid sphere. Now, we can have solid sphere. We can also have hollow sphere. When you say solid sphere, what do you mean? For example, you know a football. A football is a sphere. But if you notice, a football has a vacant space inside. If you pierce through a football, inside is open, is empty. That kind of sphere where the inside is empty is a hollow sphere. But if you have, just like your golf ball, I don't know how many of you have seen golf ball. If you try to break inside, you see that inside has something, you break. So that kind of one is solid sphere. So for a solid sphere, the moment of inertia is 2/5 mr squared. Then number three is a hollow sphere. A hollow sphere that has an empty space inside. The moment of inertia is 2/3 mr squared. Then number four is a disk. I just illustrated a disk. For a disk, the moment of inertia is 1/2 mr squared. Then number five, you have a rod. Now, of course, remember all these things, they are rotating through their centers. A rod that is rotating through the center. Remember, a rod does not have radius. An example of a rod is this meter rule. Does this meter rule have a radius? No, it has a length, not a radius. So the moment of inertia is 1/12 ml squared, length, not radius, right? Yes. Now, if number six, you have a rod this time, and the rod is rotating through the end, through its end. Please take note. This time, all these other things are rotating their centers, but this last part, if it is rotating through the end, I already explained it. Maybe it's rotating through this point, the end. Then the moment of inertia is 1/3 ml squared. These are moments of inertia that you should know. Exam would ask you, trust me, they would ask you. Now, you may ask, I have not talked about their radius of gyration. So if in order for you to get radius of gyration, it's just simply the square root of their coefficient. The square root of their what? Coefficient. So the what is the coefficient here? The coefficient here is 1. So what is square root of 1? Square root of 1, sorry, the square root of their coefficient times r. Take note. The square root of their coefficient times what? R. Square root of coefficient times what? R. What is the square root of 1? The square root of 1 is 1 times R. So which is R. Remember, square root of coefficient times R, right? I will need to refill my marker. So now this one, what is the square root? The square root is going to be square root of 2/5 times what? R. R is not inside our root. Take note. Exam will want to confuse you. R is outside the root. So what would this one be? Square root of 2/3 times R. R is outside. This one is going to be square root of 1/2 times R. Now you can still see this one as 1/√2r. So you can still see this as r/√2, still the same thing. All about this, you can still see it as square root of 1/12l, or you can still see l/√12. And the last one is square root of 1/3l, or l/√3. Please screenshot this. Tell me to move on if you are done. Tell me to move on if you are done. Tell me to move on if you are done. Thank you. Divine praise. I love that. Square root of coefficient times r. That is what I want you to be doing. Once I hit a major point, you type it so that you don't forget it, so that others will also see it. Thank you. Move on. Thank you. So I can rub the board now. So, all right. Thank you. Thank you. So I am almost summarizing this. Now, so the next thing I want to do is the theorems. The theorems. Now, you need to know that there are two theorems that govern rotational dynamics of rigid body. And why are these theorems important? Very simple. Now, it is possible. Remember, I gave you moments of inertia for different bodies that are rotating through their center. Now, if the body decides that it don't want to rotate through the center, it wants to rotate through any other point, just like I gave you. This thing usually should rotate through the center, but it now decides to rotate through the end or through midway, through any other point that is not the center. Then you need a parallel axis theorem is used when an object is rotating through an axis that is parallel to the center. It is used when a body is rotating about an axis that is parallel to the center. So if you have a body like this, and this is the center of this body, this is the center, right? Now, this is the center. Of course, the center is called center of mass. Now, let us say this body can rotate through the center of mass, but it decided not to rotate through this point. When you see this thing, it means it is turning like this through this center. And if it decides to rotate through some other point, like this, if it decides to rotate through this point, what did you notice? That this line and this line, what's their relationship? Both of them are parallel. So if an object rotates through any axis that is parallel to the center of mass, then in order for you to get the moment of inertia through that axis that is parallel to the center of mass, you use parallel axis theorem. I hope that is clear. Yes, now watch. This distance, there will be a distance between these two. Remember, this is the center of mass, which is what I gave you in that table, when a body rotates through the center of mass. So the distance between the center of mass and that parallel axis where the body is rotating from, I will call it D. if this is the distance between these two parallel axes, then the moment of inertia through this parallel axis, I'm going to call it IP. The moment of inertia through the parallel axis is going to be equal to the moment of inertia through the center of mass plus md squared. So this is the formula for parallel axis theorem. What is d? D is the distance between the center of mass and the parallel axis. What is ICM? ICM is the moment of inertia through the center of mass. That is what I gave you in that table. Let's see a simple example for this. Example. A sphere rotates about an axis parallel to its center of mass separated by a distance of 10 cm. A distance of 10 cm, full stop. Find the moment of inertia through this axis, given its mass as 5 kilograms and radius as let's say 3 centimeters. So can we attempt to solve this? Once we solve this, I will be done with parallel axis. I will go to the next theory. Now I'm giving you 30 seconds. Attempt this. 30 seconds. Remember, you need to be solving so that you don't go to exam hall to start learning. Solve this. 30 seconds. Drop your answer. Let me refill my marker while you're solving. Who has the answer? I'm waiting for your answer. I'm waiting for your answer. Ezuka says 5:45. Okay. Okay, we're going to solve now. Please, if you are joining and you are yet to subscribe, give us that support and encouragement. Now, even though I didn't frame the question perfectly well, normally this radius is supposed to be bigger than this. So, but let's just solve. You're trying to learn how to solve problems. So usually, maybe this should be around 30, this should be 10. The radius should be bigger than that particular point. So, but let's just solve it that way for now so you understand what we mean. We want to find the moment of inertia through the parallel axis. So we're looking for IP. Now, we select as what? 5 kilogram. We know the radius. The radius is 3. So let me use 3, but like I told you, this is supposed to be bigger. I would have written 30 and to make more sense. So, but let's say 3 centimeter, which you know you need to divide by 100. So this is going to be 0.03 meters, right? Yes. Now the distance, they told us the distance of 10 centimeters, that is D. As the distance between the center of mass and the what parallel axis D is 10 divided by 10 by 100, which is 0.1 meters. So with this, we can solve. First thing I want to find is ICM, moment of inertia through the center of mass. Which object am I dealing with? I'm dealing with a sphere. A sphere. Please, anytime they want you to get moment of inertia of a sphere, and they did not mention the type of sphere, the one you should use is a solid sphere. You should use a what? Solid sphere. If they want you to do hollow sphere, they will specify. But once they don't specify, then they are talking about solid sphere. So the moment of inertia for a sphere is 2/5 mr squared. So which is going to be 2/5. What is m? 5. What is our r? 0.03 all squared. So our moment of inertia ICM is going to be 0.03 times 0.03 times 2 times 5 times 5 divided by 5. So which is 0.0018 kilogram meter square. I'm sure I punched correctly. So I want to now finally get my answer. So my final answer would be using this formula. So my IP is going to be ICM, which is 0.0018 plus M5 into D. D is 0.1 squared. So if I do this, so give me 0.1 times 0.1 times 5 plus 0.0018. So this 0.0518 kilogram meter square. Now I noticed that for most of you did not convert. Take note of it. That's why you should practice questions. So take note of it. Some of you did not when solving. All right. So welcome, Blessing Chimdi, you're welcome. Please hit the subscribe button. If you are a first timer, hit the subscribe button. So, all right, can I move on? Who is saying 68 votes? Where is votes coming from, please? All right, so if we are good to go, say move on. Uchechi, good morning, welcome. Welcome. Divine praise, say I failed it. Tochi, green light. Say wait, okay, be fast, be fast. Let's be fast. I want to move to the next theorem. They say move on. Let's give Tochi 1 minute, 30 seconds to maybe screenshot it. Tochi, once you are done, say move on. Tochi, you are the one I'm waiting for. Move on. Tochi, you are done. Say move on so that I can move. I think I'll move on. Tochi is no longer. Tochi is sleeping. Okay, move on. All right. So, now remember we're looking at theorems. I have mentioned one theorem, which is what? The parallel axis theorem. Remember, parallel axis theorem is used when a body rotates about an axis that is parallel to the center of mass. Take note of the statement. The second theorem is perpendicular. I believe these two statements are easy. Perpendicular axis theorem. Perpendicular axis theorem. From the word perpendicular, what does it mean? This theorem is used when a body rotates about an axis that is perpendicular to the center of mass. That is perpendicular axis theory. And what is the formula? The formula is IZ equals IX plus IY. Don't forget, IZ equals IX plus what? IY. So that is perpendicular axis theorem, and I believe it is clear to you. Yes. Now, can we solve a problem here? Yes, but problems usually don't come out. Remember, this is a brief revision, so let's not do very complex things. You won't see much problem here. So what they just want to know, if you know these relationships, notice that it is z into ix plus what? Iy. That is the concept. That is the concept. Sometimes z can be the center of mass. You can have ICM equals ix plus iy. So this can still be written as the center of mass. Then you're looking for this or this. So take note of this. That is perpendicular axis theorem. Problems usually don't come from here. But in case you want me to solve any problem here, you can say solve or say move on, so that I will know which one I'm doing. Remember, this should be a sharp revision class. You shouldn't be wasting time. So if you want me to solve problems, say solve. If you want me to move on, say move on. If it is move on, then we want to look at kinetic energy of rotation. Kinetic energy of rotation. Please, I'm waiting for your comments. Okay, move on. Thank you. Kinetic energy of rotation. So what is rotation? Remember, we're dealing with rotational motion. We know that for linear motion, kinetic energy is half mv squared. That is the kinetic energy of a linear motion. What about rotational motion? The rotational motion, even though both of them will always give us the same answer, but you just need to know the relationship. For rotation, now let me tell you something. When you are dealing with rotational dynamics or kinetics of rotation, anytime you're studying rotation, I want you to know these things. For linear and for rotation. So there are quantities that are analogous to each other. So if you know them, you don't need to derive the formula. So for linear motion, you talk about mass, m, and mass is denoted with m. Now, the analogous quantity, the quantity that replicates mass under rotation, is inertia. Moment of inertia, rather, is moment of inertia, which is I. So it means that moment of inertia is mass under rotational motion. I believe you understand what I'm saying. Then you have velocity. This is velocity under linear motion, v. But under rotational motion is denoted as this, which is called angular velocity. Now, you also have another one. You have acceleration, a, under linear motion is denoted with a. Under rotational motion is denoted with alpha. This is called what? Rotational acceleration or angular acceleration. Under linear motion, you have x. Sometimes you use s for displacement, right? Yes, displacement, distance. You have s or x. Now, under rotational motion, you call it theta. This is angular displacement. I hope you're taking note of this. This angular velocity, this angular acceleration, this is angular displacement. I hope you are taking note of these things. So this is similar to this, this is similar to this, this is similar to this. So what else do you need to know? You need to know that, I think these are basically what you, okay, force. Under linear motion, you talk about force. Force is responsible for linear motion. Under rotation, you talk about torque. So what force is in linear motion is what torque is in rotational motion. So these are things you need to know. I think I should add one more. You have P. P represents momentum. P represents momentum. So we also have, this is linear momentum. We also have rotational momentum, which is denoted with the symbol capital N, which we call angular momentum. So take note of these things. So take note of these things. Now, if you have noted this, remember, I'm just helping you. If you have kinetic energy of rotation, you can easily get the formula from this one. So what does M represent under rotation? It is I. What does V represent? It is omega then square. So it means that the kinetic energy of rotation is Ke equals half I omega squared. I hope that is clear. Now I want to rub this. If you are good, say move on, so that I'll rub it and move to the next part. Please quickly say move on. Say move on if you are done with that. If you are done, say move on. Say move on. Okay, Uchechi said wait. So screenshot fast. Okay, move on, move on, move on. All right, so I've just explained kinetics of rotational motion. So I'm going to still give you problems anyways at the end. Let me just give overview on the topics, and then I'll give you problems, maybe 3 problems at the end. Then we are done with rotational dynamics. We'll go to the next one. So this kinetic energy of rotation. Now, there's something we call rolling motion. Rolling motion. Rolling motion is not the same as rotational motion. What is rolling motion? Rolling motion is the combination of rotation and translation. Rolling motion is the combination of what? Rotational motion and what? Translational motion. That is what you call rolling motion. For example, if you have, this is an inclined plane, and you have a spherical ball that is released from the top of this inclined plane to the bottom of this inclined plane, you will notice that as this ball is coming down, it is rotating. It will be turning. If you mark a point here, say here is A. By the time this ball gets to this point, that A might be at this point. So it simply tells you that as the ball is coming down, it is rotating. And at the same time, again, it's translated. Translation means a straight motion, right? So it translated, it moved a straight distance. So this kind of motion that involves rotation and translation at the same time is what you call rolling motion. Is that clear to you? Yes, I believe it is clear. That is rolling motion. Now, when you have an object that rolls from an inclined plane, from the top of an inclined plane to the bottom, when that object is at the bottom, the kinetic energy, the total kinetic energy that that object would have is going to be the kinetic energy of translation plus kinetic energy of rotation. That would be the total kinetic energy that the object would have. Take note of that. When an object rolls down an inclined plane, at the end of that inclined plane, the total kinetic energy it would possess would be the sum of translational kinetic energy and what? Rotational. That is to say, it will be half mv squared plus half I omega squared. You can add up these things and see. So this is one of the things you should know under rolling motion. The second thing, this is number 1. The second thing you should know under rolling motion is the velocity. Velocity. When an object is under the influence of a rolling motion, the velocity would be the combination of linear, it would be the combination of translational velocity and rotational velocity. Do you understand me? Now, when an object is translating, only translation, what is the velocity? When an object is translating, the velocity is root 2gh. Do you remember this formula? Yes, you remember it. When an object is only translating, the velocity is square root of what? 2g. That is translation and rotation. This would no longer be the velocity. The velocity will now become the square root of 2gh all over moment of inertia over mr squared plus 1. So this is the velocity of an object rolling. That is to say, it is translating and rotating the velocity. Number 3 is acceleration. Is acceleration. when an object is accelerating under a rolling motion, the velocity, the acceleration becomes a combination of the translational acceleration and rotational acceleration. Now watch. When an object is only translating, what is the acceleration? You know the acceleration is g sine theta. Remember, it's going through an inclined plane. So when an object is only translating, this is translate. This one is also translate, but this one is what? Rolling. So if it is translating, you're already used to this formula. It is g sine theta. That is where the other one will come from. But if it is rolling, the acceleration becomes square root of g sine theta over similar thing that is under here, I over mr squared plus 1. Is that clear? Yes. Is it easy to remember? Yes. So if you are done screenshotting this, say move on. Let me give you space. Say move on. Divine praise. I think I need to give you something. I love the fact that you're typing major concepts. I love that. Divine praise, Chidera. Thank you. Thank you. Now, if you are done, say move on. Say move on. Say move on. I'm almost done now with rotational dynamics. So and I will go to another topic. Some persons are never telling me to move on, and maybe they are not even getting what I'm explaining. Please, you are all participating. That's why when I explain, I will go behind to read your comment so that if anybody has a question, I will answer it. Right? Now, so this class is for everybody. So feel free to always ask your question. This is dying minute. If you are watching me now and you know you're among those that will be crossing over to UNEC, please, you don't have the same opportunity as other people. Your opportunity is one chance. You need to pass this at all costs. So, and that is why you need to be very intentional about this class and subsequent classes we will be having. Try to participate, try to ask questions where necessary. Now, I want to talk about TOG. TOG. What is TOG? TOG is the turning effect of a force. TOG is the what? Turning effect of a force. TOG is that force that causes an object to rotate. That is TOG. The turning effect of a force. This is the symbol for TOG. And what is the formula for TOG? TOG is actually the cross product. TOG is the cross product of the radius or the distance and force. TOG is R cross F. Please take notes. TOG is not F cross R. TOG is not this. This is wrong. This is wrong. This is the correct one. You see it in the exam. This is the correct one. This is what? Wrong. TOG is R cross F, not F cross R, right? Because F cross R is the negative of R cross F. So TOG is this. Now, when do you use this formula for TOG? You use this formula, this cross product that I just finished explaining. You use this formula when they give you something like they say R is, let's say, 2I plus J plus K. Then F is, let's say, I plus J minus K. Can you say that your R is given in terms of vector and your F is also given in terms of vector? Anytime they give you R in terms of vector and then F in terms of vector, they say find TOG. Please, what are you going to do? Cross product. And how do you solve this problem? Say they tell you R is this, F is this. They now say find TOG. What are you going to do? Please, for cross product, you're going to use metrics. So your TOG is going to be IJK. Then you arrange R. Remember, you're starting with R first. So you arrange R, which is 2, 1, 1. Then you arrange F, which is 1, 1 minus 1. Please, did I just teach you how to solve this? Yes, if you can solve this. say move on, so I don't need to do it. If you can solve this, say move on quickly. Say move on if you can, so that we don't waste time there. Say move on if you can solve it. If it's hey, praise God, say be calming down. Okay, I think I'm fast, but I'm just trying to cover much topics. Okay, no wahala. So I'll solve it for the sake of some persons that joined late. I'll solve it. So now let me calm down. Oh, now torque. This is the formula for torque, right? Torque, we said, is the turning effect of a force. So meaning that torque is that quantity that causes a body to rotate. That is torque. And what is the formula for torque? It is R cross F. So when you see torque given in terms of cross, it means that your R must be given this way as a vector, and then your F must also be given as a what? Vector. Once they give you this, then this is the formula you would use. We have about 4 formulas for torque, which I'll be giving you. I'm just giving you one now. So, and we have an example to solve. So, to find this, we arrange in matrix form, just like you know cross products. You start with I, then arrange the coefficients of R, then you arrange the coefficients of what? F, right? Now, to solve this, what we do is we put I. We start with I. Close everything that is connected to I, vertically and horizontally. So you close this. You close this. Once you close that, what can you see? You can see 1, 1, 1, and minus 1. So you put it 1, 1, 1, and minus 1, right? Now, the next, remember in matrix, this place is always plus, this place is always minus, this is always plus. Don't forget. Now, I am done for I. Then I will go for what? For J. So this is minus J. Minus J. Now, the same thing for J. I'll close, this time I'm dealing with J. I'll close everything that's connected to J. So which this one is connected to J. And then I would also close this. So if I close that, what can you see? 2. 2 and 1. Then 1 and minus 1, right? Then finally I will go for K plus K. I'll do the same thing for K. This time I'll close everything that's connected to K. So I'll close this, and then I'll close this. So what can you see? 2, 1, 1, 1. 2, 1, 1, 1, right? Yes. Now what do we have? You start with I. Now watch the concept. 1 times minus 1 is minus 1. You immediately put a minus. The moment you multiply 1 times minus 1, you write your answer, you put a minus. Then you go the other way. 1 times 1 is what? 1. Did you see the idea? Don't forget. Now I'm done. I'll go to this one, which is minus J. I'll multiply. 2 times minus 1 is minus 2. I'll put minus. 1 times 1 is 1, right? I'll close. I'll go to K plus K. Now 2 times 1 is 2. I'll put a minus. 1 times 1 is 1, right? So what do I have here? Minus 1 is what? Minus 2. Minus 2 times I is minus 2I. I'll come here. Minus 2 minus 1 is minus 3. Minus 3 times minus J becomes plus 3J. Now 2 minus 1 is 1. 1 times K is plus K. So this is what I have as my torque. Now, if it is clear to you, please say move on. Please, I am really sorry for being too fast. In case you have a question, don't hesitate to ask. All right, and I'll check and attend to it. So if it is clear, say move on. Somebody solved already. Lone Wolf, and Lone Wolf got it. Thank you, I love that. Mesoma say move on. Lone Wolf say move on. Chechi say move on. Uzo say move on. All right, I think I can move on with these comments. So please, if you are yet to subscribe, do us that favor of subscribing. don't forget to share this link with your friends. You can do that now. You can still just share it with your group and come back and join us. We need them now, and I'm very happy that you are really pushing this channel. We are already heading to 4K subscribers. I believe that in the next few days we will hit 4K subscribers, and it is you, and it's also in your set that we got monetized, and I really appreciate your set. It's full of good luck, and that same good luck will follow you in your exams. Now, this is TOG. TOG is R cross F, right? I've given you one. So you use this formula whenever you are dealing with the vector forms, right? Which is clear. Another formula for TOG is TOG equals F times R. So this is also a formula for TOG. In this case, they will give you F as a number. They can tell you that F is 20 Newton. Tell you R is 15 meters. So you can see that F and R are numbers. They don't have I, J, and K. Once they give you F and it does not have I, J, and K, it means that F is a scalar. They give you R, it means that they have given you not necessarily scalar, they've given you their magnitudes. So once they give you F and R without I, J, and K, then this is the formula you're going to use. So for example, they tell you F is 20 and R is 15. They say find the TOG. The TOG is simply going to be 20 times 15. You use this formula. You know when to use this, when you have R in terms of vectors, right? When you have R in terms of magnitude, you use this formula. Don't forget, this thing is still the same thing as RF. FR is RF is the same, but not in this case. Another formula for TOG you should know is that TOG is moment of inertia times what? Alpha. Right? How did I get this? By knowing that force is ma, and you know that mass is moment of inertia, acceleration is this, so this is also a formula for TOG. Is that clear to you? Yes. So I've given you how many formulas for TOG? 3 formulas. So why am I giving this? One of the past questions I have for physics, they give a question, they say one of the following is not a correct formula for TOG. So they may not even ask you to calculate. Know these things. So this is TOG. And you also know that TOG is I times the squared theta over the t squared. So this is also a formula for TOG. I've given you how many formulas? 4. 1, 2, 3, 4. These two are very much similar because alpha is actually the squared theta over the t squared. So this is actually alpha. So that's why these two formulas are still the same thing, right? Yes, because alpha is equal to this. Now, I believe that the concept of TOG is very clear, and you know that TOG is a vector quantity. TOG is a what? Vector quantity. I believe you know that. What is the unit of TOG? The unit is Newton meter. The unit of TOG is Newton meter. Now, let's go to power. And that is the last thing I'm doing, power. And I'm done with rotational dynamics. Power. Okay, I'll still talk about momentum, angular momentum. So power. What is power? Power is the rate at which work is done. Power is the rate at which work is done. Very simple. If I have 2 young men and I tell them to carry a bag of cement from point A to point B, if the first person carries his own under 3 seconds and the person carries his own under 30 seconds, who has more power? The person that carries his own under 3 seconds. So power is how fast you can do work, the rate at which work is done. That is power. And power has a formula which is work over the time. So the time rate of doing work, power is work over time. So, and what is power? What is work done? Work done is force times distance. So it means that power is force times distance over what? Time. Please, do you know that I can write this as force times distance over time? Are you aware that these two things are the same? Yes. So please, if you still remember, what's the formula for distance over time? What does distance over time stand for? Distance over time is velocity. So I can still say power is Fv. So power, I've given you some formulas for power. Power is work over time. Remember, work can still be kinetic energy. Work can still be half mv squared. Work can still be force times distance. Work can still be mgh. It depends on whatever they give you. Work can be half mv squared. Work can be fd. Work can be mgh. All of them are what? Work. Is that clear to you? Yes. So power is work over time, fd over time. Power is also force times velocity. Is that clear to you? Yes. Now I want to also give you the formula for power. This is power under translation or linear motion. So power under rotation. What is the formula? Please, the equivalence of force under rotation is what? Is torque. The equivalent of velocity under rotation is what? Omega. So it means this is a formula for power under rotational dynamics. This is the formula for power. Let me give you an example. So there is a question. Find the power of a rotating fan with a torque of 12 Newton meter and an angular speed of 150 rpm. So I'm going to solve this question straight away. Now, can I rub this part? Yes. Can I rub this part? Yes, so that I can solve that question. The question says, find the power of a rotating fan with a torque of 12 Newton and an angular speed of this. Now, please take note. In this particular formula, omega is angular speed, but this omega is measured in radian per second. It is measured in what? Radian per second. Now, let us solve this problem. They gave us torque as 12 Newton meter. We are looking for power. We don't know power. Now, they gave us angular speed, but the angular speed they gave us is measured in RPM. Please, what does RPM means? RPM means revolution per minute. Revolution per minute. Revolution per what? Minute. So it means that is angular speed, but that is not the SI unit. So if I want to convert it to omega, what is the relationship? Omega is 2 pi n over 60. So it means that what they gave us in this question is n as 150 rpm. They gave us n as what? 150 rpm. So it means you need to convert it to omega to be able to find power. So how do I find omega? My omega is going to be 2 pi times n. What is n? 150 divided by what? 60. So if you solve this, you get your omega before you can now find power. So what is my omega? 2 times pi, which is 3.142 times 150 divided by 60. So my omega is 15.71 rad per second. That is my omega. Can I get power now? Of course, yes. My power is torque times omega. What is my torque? 12. What is my omega? 15.71. So if I punch this, I have times 12. So this is 188.52 watts. Power is measured in watts. So if it is clear to you, please tell me that it is clear. Take note of this relationship. You'll meet this under rotational kinetics also. So take note, if it is clear, say move on. If it is clear, say move on. If it is clear, say move on. Okay, somebody has gotten it. Divine praise, got it already. Somebody is asking, hope is UNM based. Which other base am I using? And of course, you should know that all the universities are using similar curriculum. So, but I'm using UNM textbooks. Hmm? So I should move on. All right. So I want to talk about angular momentum. Angular momentum. Remember, we have linear momentum, which is a topic we're going to study again very briefly. So angular momentum is actually the moment of linear momentum. Angular momentum is what? The moment of linear momentum. You should note that. I repeat again, angular momentum is the moment of linear momentum. Just like you say, moment of inertia. So the moment of linear momentum is called what? Angular momentum. So angular momentum, you can still define it as the turning effect of what? Linear momentum. So that is angular momentum. And what is the formula? Angular momentum is actually linear momentum, which is P times R. Angular momentum is linear momentum times R. Please, what is linear momentum? Linear momentum is mass times velocity, then times R. So this is the formula for angular momentum, mvr. mvr. This is the formula. Or you can still say, please note, linear momentum P is mv. Don't forget this. But angular momentum is P times R or mvr. Now, I can still get another formula for angular momentum from this. What is the equivalence of mass? The equivalence is moment of inertia. What is the equivalence of velocity? It is omega. So this is also another formula. So this, and these are formulas for angular momentum. Is that clear to you? Yes. We also have what we call the law of conservation of angular momentum. Law of conservation of angular momentum. What does this say? Quickly, I will say it, I won't write it. The law says that when the net torque, when the rate of change, when the net torque is constant, then angular momentum is conserved. If the net torque is constant, then angular momentum is conserved. That is just it. If the net torque is constant, angular momentum is conserved. So I think I'm done with this. I'm done with rotational dynamics. So we have hit 2 topics, and I think I tried to even give them in great details, but I was hoping I'll be summarizing these things, but I was too detailed. So let's move to the next part. Let me quickly do unit and measurement, the part most of you may neglect. That is where the exam begins from. Unit and measure. I've done 2 big topics. These are smaller topics. I've done 2 big. I'll go to small. I'll go to another big one. So I'll try to see if I can do up to 5 topics. I've done 2. Let's do the third one. Let's see if we can do 5. Then solve some random problems and allow you to go and rest. Now, unit and measurement. Now, I told you that physical quantities can be classified based on units, and they can also be classified based on direction. So based on direction, you classify them as vectors and scalars. Based on units, you can classify physical quantities into fundamental quantities and derived quantities. So physical quantities can be classified into what? Fundamental quantities, which actually gives rise to fundamental units. So what are fundamental quantities? Fundamental quantities are the quantities upon which other quantities are built. What are fundamental quantities? They are quantities upon which other quantities are what? Built. So it means you can call them base quantities. You can call them what? base quantities. So, and we have 7 major fundamental quantities. There are 7. So it means that if you know these 7, any other thing that is not part of them becomes the second type, which is derived quantity. So all you need to know is to know the fundamental. So very quickly, we'll call them quantities. I'll call their symbol and their unit. So I want to give you the 7 of them. Number 1 fundamental is mass. What is the symbol of mass? The symbol of mass is small letter m, not capital letter M, small letter m. What is the unit? Next, length. The symbol is small letter L. The unit is meters. The next is time. What is the symbol for time? Is small letter t. The unit is what? Seconds, that is S. What is the next? The next is temperature. Temperature, the symbol for temperature is capital T or sometimes theta. So what is the unit? The unit is Kelvin. The next is electric current. Electric current, what is the symbol? The symbol is capital letter I. Sometimes some books use small letter I. So the electric current is I, capital or small. Then what is the unit? Ampere. The next is luminous intensity. Luminous simply means light. So intensity talks about brightness of light. How bright is light is what you call intensity. So luminous intensity, light intensity, is denoted with capital letter I. What is the unit? CD, candela. Candela. I CD, that is the unit. Then finally, you have amount of a substance. Amount of a substance, which is what we call number of moles if you are studying chemistry, but you call it amount of a substance, still same thing. What is the symbol? Small letter n. What is the unit? The unit is mole. So all these things I've mentioned, these 3 are the most important to us. So all these things I've mentioned are what you call fundamental quantities. It should be in your consciousness. All right? So remember, fundamental quantities are the base units. Now, number 2 type of quantities you should know are derived quantities. Right? What are derived quantities? Let me shift for those that want to screenshot this. So what are derived quantities? Derived quantities are quantities that are obtained by combining 2 or more fundamental quantities. Derived quantities are quantities that are obtained by combining what? 2 or more fundamental quantities in multiplication or division. That is derived quantities. So now derived quantities are innumerable. There are too many. You can't know all of them. So, but I'll be giving you the necessary ones that you need to know for your exams. So very quickly, let's start from the easiest, which is area. Area is denoted as A. Please, under unit and measurement, I need you to know that length is considered to be the same as distance. Under unit, length is considered to be the same as distance. It is also the same as radius. It is also the same as height. It is also the same as diameter. It is also the same as displacement. Under unit, length, distance, displacement, radius, height, width, breadth, diameter, all these things are the same as length. So when you're solving, you are using the same units for all of them. I hope it is clear. Now, what is area? Area is length times breadth. You know that. So what is the unit of length? The unit of length is meter. What is the unit of breadth? It is also meter. So meter times meter is meter raised to power 2. That is meter squared. Meter what? Squared. Remember, this meter is carrying a power of 1. This meter is also carrying a power of 1. So when you multiply them, you add their powers, which becomes meter square. So that is area. Now I'm quickly going to teach you how to convert before I move on. But let me give you the next. Volume. Volume is V. What is volume? Length times breadth times width. So what is the unit? This is going to be meter times meter times meter. So m is going to be m raised to power 3. It's going to be m raised to power what? 3. Now let me quickly show you how to convert. So I don't forget it. Now remember the SI unit is meter times square. Remember, area is always measured in the square. So they give you area as 50 centimeters squared. How do you convert it to the SI unit, which is meter squared? Now look at concept. If you want to change centimeter to meters, what do? When you are changing centimeter to meter, you divide by what? 100. Now because this is centimeter squared, what will you do? You now square your 100. That's how to convert square to meter square. So if you solve this, what will you have? You would have 50 divided by 100 square. So which would give you 0.005 meter square. Now I believe this is clear. If you understand, I give you volume as 25 centimeter cube. Please convert to meter cube. Tell me the answer quickly. Drop the answer quickly. Drop the answer quickly. Thank you, divine praise. Thank you. Okay, somebody has solved. King Joker has solved. Any other person? He deleted it. Oh. Okay. All right. I'm seeing different answers. The calculator that is the challenge. So you're going to do 25 divided by 100 raised to power 3 this time around. Raised to power 3, not 2. So why? Because there's cube. So you have 25 divided by 100 raised to power 3. So this is going to be 0.00005 meter cube. That's 4 zeros. Or you can put in standard form 1, 2, 3, 4, 5. 2.5 times 10 to the power minus 5 meter cube. So this is the answer. So I don't know why people did not get it right. So Uchechi got it. Other people did their answers. It's 4 zeros. It's 4 zeros. Take note of that. So now let's move on. Remember, we're looking at the right quantity. I just had to teach you how to convert because it's still on that unit. So you have volume. The derived unit for volume is meter cube. So you have velocity. What is velocity? Velocity is displacement or distance over what? Time. Velocity is displacement or distance over time. Under unit, velocity and speed are the same thing. Under unit. So now velocity, which is same thing as speed, is displacement over time. And what is the unit of displacement? It is meters. What is the unit of time? It is what? Seconds. So whenever you have something under and you're bringing it up, now notice that S, the power S is 1. So it means you can write it as meter S to power minus 1. That is meter second. This is how we'll be writing it. Or you can say meter slash S. Or this is the one we'll be using more. They are the same, but this is the one we prefer to be using. So take note of that. So now we also have acceleration. acceleration is velocity over time. Acceleration is velocity over time. So it means you want to get the unit of acceleration is going to be velocity, which is meter per second all over second for time. So watch, this is going to be meter per second. When this second again comes up, it becomes per second again, right? Yes. So you have meter, watch. This power is -1, it becomes -2. Seconds per -2. So this is acceleration, right? Then you have force. Force is MA. Force is MA. What is the unit of force of mass? Mass is kilogram. Acceleration is meter per second square. So this is the unit of force, kilogram meter per second square, which physics people under unit and measurement decided to call this Newton, which is the same thing. So it means that 1 Newton is same thing as 1 kilogram meter per second square. Is that clear to you? Yes. Now, you also have what you call pressure. Pressure is force over area. Now, what is the unit of force? The unit of force is kilogram meter per second square. The unit of area we got as meter square. So what do you have? Notice what I'm going to do. You have kilogram, then you have meter. Now when this meter with a power of 2 goes up, it becomes meter with a power of -2. Then you have second with the power of -2. So this is going to be kilogram. Watch. This first meter has a power of 1. So 1 minus 2 is what? -1. So you have meter -1, second -2. So this is the unit per meter per second square. Kilogram per meter per second square. Of course, they still agreed again. Instead of writing this long thing, they still agreed to call it Pascal. Pascal. And of course, say you don't want Pascal, you should know that force is Newton and this is meter square. So you can say it is Newton per meter square or Newton per meter square. So any one of them would do. That clear? Yes. I'm trying to give you all the ones that usually comes in exam. Right? Yes. Now you also have, I'm almost done with this topic. Once I've finished these things, I'll move to dimension. Once I finish dimension, I'll tell you the uses of dimension and I'm done. I'll go to the next topic. Now, you have another one, surface tension. Surface tension. So surface tension is force over length, force per unit length. What is the unit? It is Newton over meter, which is Newton per meter. I hope that is clear. You can still solve using this. Still the same story. They will ask you for surface tension. They can also ask you for viscosity coefficient of viscosity. They will ask you for that. They will ask you for coefficient of viscosity. Now, viscosity is actually viscosity. Let me give the formula. That is force over area equals viscosity velocity. Viscosity force over area. So force times L all over area times velocity. So this is the formula for viscosity. Force times length all over area velocity. So this is the formula for viscosity. With this, you can get the unit of viscosity, right? Yes, the unit of viscosity is going to be, if I come to solve, force is kilogram meter per second square, length is meter, all over area is meter square, which is meter times meter. Meter square is meter times meter. Velocity is meter per second, right? So let's cancel what can cancel out. This m can cancel m, this m can also cancel m. So what do I have? I have kilogram. I hope I've not increased my speed. I hope I'm not fast yet. So you have kilogram. Now there's one m under, and that m has a power of 1. When it comes up, it becomes m to power -1. Right? Yes. You have s above, s to the power minus 2, and you have another s under. This s to the power minus 1. When it comes up, it becomes s to the power 1. So when you add up these things, you have kilogram per meter, then minus 2 plus power 1. Watch it carefully. S is minus 2, then plus this power 1. It becomes minus 1. So you have s to the power minus 1. So what is the unit of viscosity? Kilogram per meter per second. Don't forget, don't cram it. Just learn how to derive it. Note all these formulas I'm giving you. You'll be needing them. So also, viscosity can be called poise. Poise, from a man, a scientist known as Poisuli. So that's the unit of viscosity, poise. So then they can also ask you for momentum. So momentum is mass times velocity. So you can always find this is easy, kilogram meter per second. Kilogram meter per second. Now, I want you to note that momentum has the same unit as impulse. That is an exam question. Momentum has same unit as impulse. Don't forget. Momentum is mass times velocity. Impulse is force times time. So momentum and impulse have same units. Which other quantities have same units? Pressure. Pressure and modulus, Young's modulus. Modulus of elasticity. Pressure and modulus. Pressure and modulus have the same units, and also pressure, modulus, and stress. Pressure, modulus, and stress. That's tensile stress, right? Pressure, modulus, and stress have the same unit. Don't forget. Momentum and impulse have the same unit. Don't forget this. And also, I want you to also note that strain is what? Unitless. Strain is unitless. I need you to note that strain is unitless. It does not have units. I want you to note that theta has a unit of radian or degree. Theta has a unit of radian or degree. So theta is not unitless. Theta is not unitless, but it is dimensionless. Theta as angle is not unitless, but it is what? Dimensionless. While strain is both unitless and dimensionless. So it means that it's possible for a quantity to be unitless, to be dimensionless, but would have a unit. Am I clear to you? Is it clear? Yes. Can I run? Yes. So if you want me to move on, please say move on quickly. Say move on. Say. Thank you, divine praise. Okay, say wait. Uchechi, say wait. So please, I'll need you to give me 1 minute. Let me drink water. Feeling very thirsty. 1 minute. All right, I'm back. When we change topic, tell me. Okay, seems like some people are very good with this topic. Okay, so does it mean I should end this topic so I will know? Does it mean I should end this one? Tell me. So I'll know if you are too good with this. So now you need to also know how to find the unit of energy. So let's stop there. Now we want to quickly end with dimensional analysis. Dimensional analysis quickly. Dimensional analysis is just a, a mathematical way of relating physical quantities, right, in terms of their exponent. Just a mathematical way of relating physical quantities in terms of their what exponents. The exponents are actually what we know as the dimensions. So in order for us to do dimensional analysis, we introduce new symbols, and those new symbols we call them dimensions. So for example, we have mass. The dimension of mass is capital letter M, not small letter. Small letter M, you're talking about the symbol for mass. So, but for dimension, the dimension of mass is capital letter M. You have length. The dimension of length is capital letter L. You have what again? You have time. The dimension of time is capital letter T. Now, you can see something like this in exam. Please take note, if you are dealing with mass, I can still decide to write mass, write length, write time. I'm still dealing with mass. But in order for me to tell you that I'm dealing with mass, I'll put 0 for length, put 0 for time, because I know that L raised to power 0 is 1, T raised to power 0 is 1, so I'll be left with only mass. So it means I'm still dealing with mass. For under length, I can still write M, L, T, right? So since I'm dealing with length, it means my M will carry 0, my T will carry power 0. Now for time, I can still write M, L, T. Since I'm dealing with time, my M will carry 0, my L will carry 0. So M and this is still the same thing. L and this whole thing is the same. T and this whole thing is what? The same. So this is the dimension of time and so on. So you need to know this. Now very quickly before we proceed into other dimensions, I want to give you the rules. Rule number one, rules that are used in dimensional analysis. Rule number one, I want you, while we're doing this, we're already rounding up. In the next 5 minutes, I should be done with this, right? Now, I would like you to also suggest topic, then I'll pick the next from your suggestion. So, rule number one, if two quantities have the same dimension, then they can be added or subtracted. If two quantities have the same dimension or unit, they can be added or what? Subtracted. That is to say, quantities can be added or subtracted provided they have the same dimension or the same unit. So this rule is applicable to unit. It's also applicable to what? Dimension. So that is rule number. I don't need to write to waste time. Rule number two, two quantities can be equated if they have the same dimension or unit. Two quantities can be what? Equated if they have the same dimension or unit. That is to say, let me explain number one. If I say x plus y, it means that the unit of x should be the same as the unit of y. If I tell you that the unit of x is meters, then what is the unit of y? Automatically it should be meters. That is why I am able to add them. That's why I'm able to add them, right? Yeah, so you use that idea. If, for example, okay, I'll give you an example at the end. Now, rule number two, I said if you equate quantities, it means that they have same unit. So if I tell you that x is equal to y, and I tell you that the unit of x is seconds, please automatically, what is the unit of y? It is what? Seconds. Rule number three, in dimensional analysis, you ignore constants, you ignore numerical constants, you ignore numerical constants. When you say numerical constants, numbers like 2, 3, 4, 1/2, and so on. So you're dealing with kinetic energy. You have half mv squared. So if you want to get the dimension of kinetic energy or the unit, you ignore half, because it is not, half does not have a unit. So these are the rules you need to know in dimensional analysis. So let me give you examples and then round up. So I want to see your suggested topics, because I'm almost done with this. Let me see your suggested topics. So the messages becomes too much. People they say I'm fast. My God, I thought I'm even being too slow. My God. You're not saying anything. You're not saying anything. I'm seeing equilibrium, simple harmonic motion, conservation of momentum, simple harmonic motion. Okay. Which other one? All right. So very quickly, I want to take one example here. So we have the displacement of a particle is given as S equals A plus BT plus CT squared. To stop, where S is in meters and T in seconds. Find the unit of ABC. So we're going to quickly solve this. So they said the displacement of a particle. Now let me allow you to digest it, so that it won't look like I'm too fast. So read it, digest it, then let's solve it quickly. Giving you 30 seconds to attempt it. In fact, attempt it. Giving you 30 seconds to attempt it, so that while I'm solving it, it'll be clearer to you. I think I will only solve this question and one more, and I'll move on. Right, so I'm giving you this thing, so solve it quickly. 30 seconds, solve it. Who has the answer? 8 meters. Okay. I'm waiting. Only Uchechi and okay. All right, I think I should solve now. So, the question says the displacement of a particle is given as this, where S is in meters and T in time. Find the units of A, B, and C. So quickly, I have S as A plus BT plus CT squared. So this is what I have. And we're going to use the rule I gave you, that two quantities that are equated have the same unit. So the unit of S is meters, and S is equal to A plus BT plus CT. So it means that the unit of A should be the same is in meters, since S is in what? Meters. Same way, this has the unit of A, or you can say this has the unit of S. So BT has the unit of S or the unit of A, which is what? Meters. But you're finding B. So if you make B the subject, you have M over T. So, and you have M over T. T is seconds. So it means that B is meter per second. Is that clear? Yes. Then this one is CT square equals what? Meter. This CT square also has the unit of meter. So C becomes meter over T square, meter over second square. Then C becomes meter per second square. So these are the answers. And I believe that most of you got it. So with this, I will stop for now. I think I'm done with unit and measurement. So you should know the uses of unit and measurement. You should know them. One of the uses is that unit and the unit of dimensional analysis, the uses. Dimensional analysis can be used to obtain the unit of a physical quantity. Dimensional analysis can also be used to suggest the relationship between physical quantities. So you can use it to suggest the formula that connects physical quantities. As one of the use of dimensional analysis. Dimensional analysis can also be used to check the accuracy or correctness of an equation. So I think I'm done with this topic. Hope I can rub this. So which one are you suggesting? Now let me know. Which topic are you suggesting that we do next, so that I will know? If you are joining us and you are yet to the subscribe button, which one are you suggesting? The last suggestion I saw is Newton's law of motion. This one, okay, simple harmonic motion is becoming prominent. Somebody says static equilibrium, there's nothing in simple harmonic motion. I don't know why most of you are saying simple harmonic motion. So that should be like the shortest. I can summarize that in 5 minutes. So somebody says static equilibrium, which is very big. Somebody says conservation. Let's just start with simple harmonic motion, since that is what has more votes. So the topic there is circular and harmonic motion. Circular and harmonic motion. Now, of course, it's two topics in one: circular motion and harmonic motion, and I'll just summarize both of them. Even though under circular you have so many things, you have the Newton's law of universal gravitation is here. You have Kepler's law. I don't know. I'll see if I can touch all of them very fast. Then you have your simple harmonic motion, right? Circular motion, is the motion of an object in a what? Circular path. That is circular motion, the motion of an object in a circular path. You have 4 types of motion: circular motion, you have harmonic motion, which can also be called what? Vibrational or oscillatory motion. You have your random motion, you have your translational motion. These are the 4 types of motion you have, which you should know. Now, under circular, we can still call circular rotational motion, even though they are not exactly the same, but they are similar. So we can still call it, if we don't call it circular motion, we can call it rotational motion. At least to a great extent, they are similar. So now under circular motion, we want to look at the kinetics of circular motion. Kinetics of circular motion. Kinetics is just the aspect that studies the motion of an object in a circular path. Kinetics of circular motion studies motion of objects that are moving in what? Circular path. And if you want to study kinetics of circular motion, you need to know some terms that are used in circular motion, which I have explained already somehow. One of those terms is angular displacement. These are the terms you will be hearing under circular or rotational motion. I've mentioned this today under dynamics, rotational dynamics of rigid body. So angular displacement is denoted as theta. This is what? Angular displacement is actually the distance covered by an object that is moving in a circular path. So if you have a circle like this and an object is at point A, this is the center. An object is at this point A. If this object moves from point A to point B, it has covered this distance AB, which is the length of an arc, and the angular distance it covered is theta, but the linear distance it's covered is the length of the arc, which is S, right? So angular displacement is the distance that is covered in a circular path. It is measured in radian. Angular displacement of distance is measured in what? Radian. Is that clear to you? Yes. Number 2 is what you call angular velocity. Angular velocity, which is actually denoted with omega. It is denoted with omega. So what is angular velocity? Angular velocity is the rate of change in angular displacement with time. Is the rate of change in angular displacement with time. So omega is theta over time. Omega is what? Theta over what? Time. Is that clear to you? Yes, the rate of change in angular displacement with time. That is omega. And the unit is radian per second. Radian per second. Now, there's a relationship between linear velocity and angular velocity. There's a relationship between linear velocity and what? Angular. Remember, this is angular velocity. What is linear velocity? Is V. What is the relationship? The relationship is V equals omega r. That is the relationship between linear and angular velocity. Don't forget. And I didn't give you this. There's also a relationship between linear displacement and angular displacement. S is linear displacement, which is theta r. So you can see this linear displacement is angular theta r. It follows the same format, V omega r. It follows the same format. So take note of that. So number 3 is what you call angular acceleration. Angular acceleration, which is denoted as alpha. So angular acceleration is the rate of change in angular velocity with time. The rate of change in angular velocity with time. That is angular acceleration. So, and it is alpha, which is omega over time. That is angular acceleration. Is that clear? And what is the unit? The unit is radian per second square. Radian per second square. Please, I don't know if I'm too fast, but if I'm moving at the normal pace, say it's okay. Please say it's okay, so that I don't rush and some people will complain again. I hope I'm already handling the topic you want. Maybe I should leave this one again. Should I move on with this? Should I move on? Should I move on? They are not talking. Should I move on? I should leave this topic and enter conservation. Somebody say conservation. I should move on. Ocha say yes, sir. I should move on. Lone Wolf say move on. Okay, move on. All right. So angular acceleration, like I said, it is the rate of change in angular velocity with what? Time, and the unit is radian per second. It also has a relationship. So A is linear acceleration, which is angular times r. So you see that all of them have linear relationships also. So this is what you need to know for acceleration. Now, I'm sure you also know that there is something called centripetal acceleration, right? When an object is moving, is navigating through a circular path, just like you are in a car that's moving through a roundabout. There is an acceleration that keeps that car moving in a roundabout, in a circular path. That acceleration is called circular acceleration. Sorry, it's called centripetal acceleration. Centripetal. Centripetal acceleration, which is A, is a linear, so which is A equals V squared over R. A is equal to V squared over R, or you can simply say that A is omega squared R. So this is what you call centripetal acceleration, the acceleration of an object that is moving in a circular path. Is that clear to you? Yes, I believe it is clear. Now, if you have centripetal acceleration, it means you should have centripetal force, right? Even though we shouldn't be talking about force, but let me quickly give you centripetal force. Centripetal force is F equals mv squared over r. That's centripetal force, right? Yes. So you should know this. So let me give you one problem here, and then we move on. Now, so let's take this problem.